So download the test 3 from Georgia View. It's under coastal assignment. The questions here, and this is also the location for you to upload the solution. If you worry about not being able to finish all of them before midnight, you should look at it and then try to do a few questions submitted now. So then you can, there are roughly the same amount of questions, which was many, it's similar to the practice question, which has 2, 3, 4, 5, 7, 6. 13 questions. So try to finish some of them. You can upload multiple files, so you can submit some of the solution. You don't have to wait until you finish all of them to submit it, but it would be nice if they're all together. But it's, with separate files, okay as well. So as long as you submit it before midnight, and then it all counts. So it doesn't have to be a single file. It could be multiple files with multiple questions. Do you have any questions about test 3? Just try to make it submitted today to take home, because I wanted more class time rather than more exam time. The final exam is next Wednesday, so we have today's class time. We also have next Monday's class time to talk about anything that we need to, anything we should talk about before the final. All right, so today, remember to take the test 3 when you get to see the test question online. In the meantime, there are a couple of things. Did you guys fill out the course evaluation yet? Try to finish them to give us some data about the course evaluation. Is one of the assessments tool for the school. Like every class is being evaluated by the end of the semester, so students get to voice their questions, concerns, complaints. So if the class have anything bad or good, you should mention that in the evaluation. And also those numbers that you gave, a number about how responsive the class is, how was it homework, how was it book, how was the teacher. So there's a lot of grade that you can assign to the class setting, class design. So this is a valuable data for our school, and also eventually this data will be combined into a report. The evaluation itself is anonymous, but the report is useful for teacher to learn how to do better. So even if you don't have any strong feeling for any of your classes, you should still like see that like this is an average class, and then you gave on the scale 1 to 5, you give a 3, that will still be okay. But it's having the data that doesn't have a strong either way, a strong tendency, but it's better than not having the data. Having the data allows schools to actually have a clear idea of what's going on. If we have 0 data for a class, and then we don't really have any direction which way we go. Another one that you guys probably receive an email from, I think it's Michael, like one of the other professor. He was in charge of assessing all the courses and gave some recommendation. It was called a course assessment survey, but it's different from the course evaluation survey. If you click on it, it opens up. I put the link also here just so, it needs us to sign in. And so it looks like we have to sign in. Try the one from your email. If you already signed in your email, then the link automatically works for that. It was okay when I was on my computer. Now I have to sign in with my Microsoft account. So I guess I have to sign this in order to submit the survey. All right, that's how it looks like. So basically, it's a survey ask for answer to like 3 multiple choice question, 1 additional comment. It's similar to the course evaluation, but it's shorter, and it's specifically for this course. So we're trying different ways to measure how the class, in your perspective, from your opinion, from your side of it, how is it? So you can give some input on what's the future for this type of class. Remember today was a test, and I'll be any questions. So please do it either way. Both of them are actually for statistical purposes. I don't know if you guys have statistics classes before, but statistics mainly is work with data. So the more people that you get opinion from, then the more reliable the data is. So if you, our class is small, we have like 6 or 7 students, but still we need data from students. Like we could run our class, but since we have not enough students, I think it was supposed to be 4, 5, or 4. But I don't know. We'll have too few students causes us a lot of things we cannot do without enough students sign up. Anyway, let me open up today's attendance question. So we can have a record of class attendance. Actually, for smaller class, I don't have to do this, but it's becoming a habit. And also we have some, we get some exercise out of it. The one I was gonna use is this question. So this is a question about losses. All right. So this is a variable. There's 3 variables. There are variable about losses from 3 different city. The city we're calling them JKL. The losses follows distribution is. We don't have the distribution given explicitly. We're given the moment generating function for the losses. There's 3 moment generating function, therefore 3 different city. But if you look at it, you can realize that the moment generating function represented a chi-square distribution. That you might want to check what we were talking about last time. That's from chapter 5. I have a summary of all the commonly applied distribution, and this example is showing a chi-square distribution. So, like I said, moment generating function has a one-to-one correspondence between the distribution and the moment generating function. So here, in section 4. Okay, so in here you can see the moment generating function for chi-square distribution. It was this one, all right? This chi-square distribution is a gamma distribution. So in the gamma distribution, you see the format of it. Try to explain the solution to it. Okay, so you can see that there's a lot of similarity between the gamma distribution and the exponential distribution. Okay. Exponential distribution is a model for time. So gamma distribution is something that related to the waiting time for multiple successes. So in here, this theta is the mean average waiting time. Now this alpha is our shade factor, like how many success are you waiting for? So I have exponential distribution and gamma distribution in this table. I do not have a chi-square distribution. Chi-square distribution is a special gamma distribution. Is when the waiting time is equal to 2. This equal to 2, and then alpha equal to r over r. The alpha equal to 2r. So for the chi-square distribution, this is a this is a 2r. So going back to our distribution, we realize what was the mean? This is really a chi-square distribution. Like you can compare that with that. Whenever the theta equal to 2, that become a chi-square distribution. Right. So let's look at how we answer this question. We're trying to answer a third moment. The question says, let's calculate e to the x3. So that you have to recall how we use moment generating function. Moment generating function, they are called moment generating function because they were useful to determine moment. A little review. The reason that they are called moment generating function. Just a little review. Moment generating function is being defined as e to the exponent of e to the n of t. It's been defined as, let's say this is moment generating function for x. So it's expectation of e to the t times x. That was the definition. So it's mean value of e to the, this e represent expectation, also represent the average value. This e is really the number e, they're not the same e. So that because of that, this is going to be calculated like probability of the x value multiplied by e to the tx. And then you're going to either integrate this or sum up this. So if it's a discrete, it looks like this. And that's how you calculate the moment generating function. Okay. So as you can see, if x equal to 0, this will be e to the 0 equal to 1. If t equal to 0, this will be e to the tx will be 0. This will be a summation of p of x. Summation of p of x, which is summation of all the probability values, equal to 1. So m0 always equal to 1. But m prime 0, that's different. So if you calculate the derivative of the moment generating function, that was x as 0. Okay. If you make the t equal to 0 in the derivative, when you are differentiating it, as a result, x is bring to the outside. Because e to the tx, the derivative with respect to t will be x times e to the tx. So you have a summation x times prop p of x, right? It's kind of the reason that this works. So derivative, first derivative of your moment generating function give you expectation of the random variable. And then second derivative of the moment generating function will give you the second moment, which is e to the x squared. The reason for this is chain rule for the derivative. If you find the derivative e to the tx, is x t to the x. So every time you find the derivative, you have to multiply one more x. For the same reason, the moment generating function, the third derivative of the moment generating function will give you e to the x cubed. So whenever you want to find a higher order of the moment, you will have to find a higher derivative of the moment generating function. So back to this question. If we want to calculate e to the x3, what we have to do first is to find out what is the moment generating function for x. Okay, according to the statement, x represents the combined loss for all three cities. So it turns out x is equal to the summation, x equal to j, the loss for j plus the loss for k plus the loss for I. JKL, I guess there's no I. There's L. Right, so x is a summation. So the moment generating function for the x will be expectation of e to the t. See, t supposed to be tx, the x equal to j plus k plus L. All right, and then because of the exponential function have this additive feature in the exponent, so this is actually e to the tj times e to the tk times e to the tl. And we know that three different cities are independent. So because of independency, this expectation equal to their individual expectation. So it's e to the tj times expectation of e to the tk times expectation of e to the tl. So as a result, that is the first long-term function. This is the second long-term function. This is the third long-term function. So we were supposed to multiply the long-term function in order to create the long-term function for x. So this is going to be mj t times mk t and then times m lt. So basically we take all the long-term functions. Since they're all from the same base, it's easy to multiply them. So we'll have 1 minus 2t to the power of -3 times 1 minus 2t to the power of -4.5. I'm just adding it in the power, combining the power. And then times 1 minus 2t to the power of -2.5. And if you're multiplying exponent with the same base, you really are adding the power. And that's what it is. If you combine them all, and then turns out the moment general function for x is this. Right, so it's going to be 1 minus 2t to the power of negative, what is it? Negative 10. Negative 10. Then we have to find the derivative, right? We'll find the first derivative and then second derivative and third derivative. Third derivative of this function calculated when the t equal to 0. So you'll first have to find the derivative, then you make t equal to 0. That will be the third one. And that's really a calculation. Basically, all the brown part, I'm just trying to review the idea and understand, try to review the idea of how do we understand long-term function, how do we use it. On the right side, in the left side, the red are the calculation to answer the question. Maybe I did a little bit more because most of the time we can go directly from mxt to this because it's a summation. There's a summation reflected onto the long-term function become multiplication. All we were doing is multiplying the function of all three to get x. Let's finish the calculation and let me know what's your answer. Let's find the third derivative. You have to apply power rule and chain rule. Can I turn on the scanner? Six base and get rid of some of it. Ever since the computer gets updated, it's not easy to use anymore. Right, so let's see the first derivative would be, I'm omitting the x. First derivative, you move the power to the front. The power -1, which is actually -11. And then you would time a -2. That's the first derivative. Second derivative, you apply power rule one more time. -11 multiplied to the front. And then the power has to -1, so become -12. And then you have to multiply another -2 because of chain. And third derivative, we apply power rule to the variable part. all coefficient will carry. I didn't do any calculation. I just try to figure out what do we have to calculate. We'll multiply -12 power move to the front and then the power -1, which is -13. Right, because of change rule, we got to multiply one more -2. So it's -2 times -2 and then times another -2. All right, if these are all the calculation, after that we'll plug in t equal to 0 and then to get to calculate the third derivative when t equal to 0, that equal to the expectation of x cubed. Finish, evaluate, HPV. Thank you. So this is the process of determining. Thank you. So the final answer will be 10 times 12 times 2. Okay, thank you. Any homework questions? Were you guys able to finish all the homework? On what work there were all the homework from up to 5.2. On Georgia View, we have a homework, additional homework for, let me turn this off. Additional homework for chapter 4, and also one section that was 3.2. So there are 3 additional homework on Georgia View. I graded some of them. I think I still have to grade 2 more sections. But there are some in Georgia View that we should submit. The overall grades are how many questions? There are 9 questions for each section, but they were combined. For example, I think for 4.2, there are 5 questions from homework, and then there are 4 questions from the additional assignment. These are all combined because I wasn't able to find enough questions on the 4.2, so that I supplemented with some questions from the textbook. So try to go over the tested question, and if you have time, you should really open up and at least write down the question. And throughout the day, try to finish it before midnight. Any questions? Right. If not, I'm going to try to look at the final exam question, because some of the question is related to chapter 5. I worry that maybe we're not as familiar with this, so we should look at the solution to these questions. Right, so basically the task 3 is for us to practice material that we learned in chapter 5. And then the final exam partly is also for us to review what we're doing. The first few questions are from previous structure. This question number 1 is a Bayes theorem question. Question number 2, we have different percentages. It was, all right, so this is a conditional probability calculations related to chapter 1 as well. Number 3, we've got a discrete distribution. We have x and y. We're supposed to come up with a probability math function for them. Find the expectation of the following variable. Okay, so this is trying to calculate expectation for the variable. the solution is already online, so I'm trying to go through this and focus on chapter 5. Question number 4 is to determine the moment generating function. So we do have to have some idea about how to write the moment generating function, how to use it to find the moment. And this is try to find the second moment, and you should also know how to find the first moment. And this is question number 4. Number 5 is we have it's a carpet that has errors, has flaws. This is one of the homework questions, but when things are evenly distributed with very low occurrence, and Poisson distribution will be a valid model for it. And this is the type of question that will be difficult to handle if you don't have an idea of the model. And the question itself did not mention Poisson. That's kind of also made it slightly harder to do. But we really find out how many flaws per square feet. Then we can find out if the square feet increase the number of flaws, which is be multiplied by that average flaw per square feet. For example, flaw tend to be 1 every 220 square feet. So it's 1 over 220 per square feet. So you're going to find out how many flaws for 3 feet by 13 feet. You multiply 3 feet by 13 feet to find the square footage. Multiply that with 1 over 220. That's how we find the lambda for the Poisson distribution. Then this is a probability of 0. P of 0 equal to, according to the Poisson distribution, it will be e to the negative lambda. So having the right lambda is the key parameter for number 5. I do have the solution online, so if you got questions, feel free to read the solution. If you still can't understand the solution, we can spend more time talking about it. This is a question talking about uniform distribution, like uniformly distributed from 0 to 4, and how much time. It's a probably calculation for the uniform distribution. And that was one of the homework questions as well. Question number 1 or 2 in the chapter 6. It's chapter 3 assignment. And then which one was related to chapter 5? This was the chapter 3 assignment. That's a normal distribution from chapter 3 assignment. This is the relation between two variables, right? Will be a chapter 4 where we're supposed to calculate correlation, covariance between the two variables. To calculate covariance by definition, that's the expectation of x times y minus the expectation of x times expectation of y. So we would have to calculate 3 expectation. It's this example. This question, this is from chapter 5, and it's one of the chapter 5 assignments. I think it was 5.1 because we have a y equal to y equal to a times e to the x. So y is a function of x. Right? The method was, you remember how to find the density? Remember? Okay, so this is a 5.1, but I believe we should be able to do it using the method we were talking about in chapter 5. That is, if you already have the density for x, since density is exponential function, so f of x is equal to 1 over with lambda. So it would be 7 e to the negative 7x. There was lambda, not the theta, right? If it's theta, it will be 1 over 7, but if it's lambda, it's times 7. That was the average number of occurrence. Lambda is the reciprocal of theta. We don't have theta, we have. So we would already have the density for x. We're trying to create a density for y. Okay. In order to do this, we have to do a change of variable. Now, according to the relation between x and y, we will have like y divided by 8 will equal to e to the x. And then x will equal to logarithm of y over 8. We're going to use this to replace the x, since we now have an x, right? We would put in there, and then we have e times e to the -7 times x. X is ln x over y. That's changed the variable from x to y. But as we were changing the variables, since that basic function is actually a derivative, this counts for the derivative of the outside function. Now you have to multiply the derivative of the inside function. We're substituting x with this function, so you have to find the derivative of this function. Derivative of the ln is actually 1 over y. That's what we have to multiply. That's pretty much the density function for y. But normally we do a little simplification. You can move the at -7 to the shoulder. When the e and ln are together, they cancel each of those. So after you simplify it, it will look like -7 times e to the -7 moved to the shoulder, e to the ln x over 8 to the power of -7, and then 1 over y, which then equal to then e and ln will cancel. So 7 and then x over 8 to the -7, and then 1 over, it was y, right? Variable supposed to be y. 1 over y here. So altogether is 7 times negative power. You will do a reciprocal, so become 8 over y, and then 7 power. The negative is cancelled because of the reciprocal. Now we have 1 over y. We can then combine the coefficient. It becomes 7 times 8 to the power 7. The denominator is y to the power 8. So that's actually after you simplify. We don't have to simplify because they're really equivalent. This is already the variables changed. Those supposed to be a y. You can't believe all my y look like x. This is x equal to a function of y, and you can also write it as ln of y minus ln of 8, right? If you write the logarithm of a division equal to logarithm of subtraction, that kind of explains the derivative, because the derivative of ln y is 1 over y, derivative of the number actually equals 0. So that's why I'm only multiplied by 1 over x. This is the density function for y. All the other one is for the sole purpose of trying to simplify. Any question? That was one of the examples from 5.1. And then we have, this was one of the number choices, right? It was one of the chapter 1 homework. That's 16C3 was a calculation. And I guess that's all. So it looks like I don't have that many. That's weird. I felt like I might have more questions on that. Let me see. I hope I didn't put the wrong file up. Right, I guess that's it. This is a 11 question, so it should be and that was the final answer if the variable is t. But I think the variable is t because the homework was using the t. But if the variable is y, it would be this. Right, that was where I landed as after simplification. The solution set here is more like detailed than what I was writing over here. But you see, so it looks like it didn't put a lot of stuff. This for chapter 5, and we did talk about it, but it looks like there's not a lot of chapter. There's not a lot of chapter 5 here. There's more chapter 5 on the test 3 I posted. This one actually heavily focused on chapter 1, 2, and 3. I kind of labeled which homework it was related to, So if you are having some issue or need more practice question, you're welcome to look up the homework assignment. See that was 1.5, number 5, and this was 2.2, number 10, with that assignment. And this is, I didn't label that one. I guess maybe there's not a match to it. This is homework 2.3, number 5, and 2.7, 3.1 for uniform distribution. This was 3.1, number 8. That was 4.2, number 6 for the relation between the two variables. This is 5.1, number 7. So I think the solution there pretty much indicated which question we should practice more. Any questions? All right. So, and the final exam, our final exam is quite close. We only get 1 week to practice, so hopefully we don't have to stress about it if you kind of know these questions. Any questions?
Do we get a note card on the final?
Yes, you can use a note card, a formula card. Any questions? Right. If you want to review what we were talking about, I was going to try to use this as an opportunity to review chapter 5. I guess it's better to use the test 3 question as a review. Any review? Test 3 was designed for chapter 5 anyway. So again, this set of question solutions is already online. If you look at the question number 1, we have 2 random variables. They're from the same distribution. So that means x1 follow this distribution, x2 also follow the same distribution. Because they are from the same sample, they're random sample from the same distribution, they were supposed to be independent. So theoretically, whenever you see a random sample size something, size 2, size 5, whenever it's a random sample from the same distribution, we're assuming the random variable in the sample, they are independent from each other. So whenever you see a random sample, you already are indicating these variables are independent. So to answer the question, you apply the fact they're independent a lot. For example, the first question, when we're calculating the probability of the event, we actually assuming this probability can be calculated by multiplication. So if probability A and B are independent, so this probability is equal to probability of one thing times probability of another. And this is called by the independence of the event. So we would calculate probability X is between 1 and 0.25. That was 1. And then the other one was probability that X2 or X1, they're actually from the same distribution, is between 0.5 and 0.05. Yeah. So basically, you can separate the calculation now because of independent. Originally, if these 2 variables are not independent, we have to do a double integral, right? We have to find a joint distribution and do a double integral. But now, since they are independent, we can calculate each one of them by itself. So, for example, the first one, we will calculate it with the integration of the density. So we'll integrate from 0.25 to 1. We'll integrate this density, so it's 4 e to the negative 4x dx integrated from 0.25 to 1. That's how we calculate the first one. To calculate the second one, it's integration from 0.05 to 0.5. Integrate also the 4 e to the negative 4x dx. So we'll be integrating the same function, but with different integration. Any question? So I'm just trying to explain the idea, but skipping the calculation part of it, because the integration all takes a little bit of time. But if you're doing it at home, I guess you can use like Simulab. Does the calculation of integration a lot faster than we can do manually. Now, for the same reason, because of the independence, we're able to separate the expectation. So because x1 and x2 are independent from each other, so you calculate expectation of x1 by itself. It's multiplied by expectation of x2 minus 0.25 to the power of 2. So that's indicating that we are looking at two separate calculations, each with a less complicated scenario. Now, if you are calculating this one, that is an expectation of a expectation of exponential distribution, right? For exponential distribution, this one, the mean value is, see, the theta is 1/4. If you think about it, right? And that is exponential distribution. Normally it's 1/theta, right? Right now 1/theta equal to 4. So therefore theta equal to 1/4, right? You always do a reciprocal to the coefficient. So do try to think around that. Because theta equal to 1/4, so we know that the exponential distributions average equal to theta. So we know this one is 1/4. That was the means. Right. Because the mean equal to 1/4, there's the 0.15 is the 1/4. This is the theta minus the mean square. So it's a square deviation from the mean according to the definition. That was the variance. That was the, so this one is really the mean, the theta, we can also say the mean. Okay. This one is really the variance. Okay. Variance for the exponential distribution is supposed to be the theta square, and this is actually supposed to be the theta, therefore it's 1/4. This variance is theta squared, so it's going to be 1/4 squared. So this is a quick way to answer the expectation. If you remember the value of the mean and value for variance of the exponential distribution. Any question? So that's how we answer B. So you can pretty much answer part B quickly if you remember that was supposed to be the variance of the variable, but that was supposed to be the mean of the variable. That was supposed to be the variance of the variable. So knowing the meaning of the expectation helped us simplify the calculation. For part A, there's no quicker way. We'll have to do the calculation of the equation. Or if you remember the cumulative distribution function for exponential distribution, it was 1 minus e to the x over theta. Remember the cumulative distribution, you do the substitution, subtraction of the exponential. So it's going to be 1 minus e to the -4 for the upper limit, and the lower limit will be minus, the lower limit will be 1 minus e to the -4 times 0.25. And that will be the calculation, because I already knew the antiderivative of the function, or I already knew the cumulative, the CDF. Calculation probably is integration of the PDF, but if you already have the CDF, so it will be the CDF of the upper limit minus the CDF of the lower limit. So one way or the other, it should be the same value. Same thing for the second one, you plug in 0.05 and 0.005 to the CDF. So it'll be a 1 minus e to the -4 times 0.5 minus 1 minus e to the -4 times 0.05. That would be a similar calculation to it. So it does help if we remember the CDF. So you could write the CDF and PDF for exponential distribution on your formula card. That should simplify some of the calculation. Any questions? Okay, this is question number 1. Number 2, we have a discrete situation. X2 and X1, X1 and X2, they're a random sample size 2 from a discrete distribution. So we want to find the distribution of y. Y is the summation, determining the mean and variance for it. Okay. So this is one of the situations. I think it's better if we use the fact that they are a random sample. So So therefore, the random sample, so they're independent from each other, and there are multiple variables. So we can apply what we have. We can use the moment generating function approach. So for this, they what is the distribution? So we would have like the moment generating function for variable x would be this is the moment generating function. It will be the probability time e to the, so x equal to 1, its probability is 1 over 10. E to the expectation, right? When you calculate expectation, it's probability times the value. The value is e to the t times x, so t times 1, right? Plus 1 over 2 over 10. Second value is x equal to 2. Right? Following that formula, x equal to 2, so we have 2 over 10. And then e to the, we're calculating e to the expectation e to the tx. How do we calculate expectation? It is a summation of probability of x e to the tx. Depending on the x value, x takes out 1, 2, 3, 4, so the summation is 1, 2, 3, 4. So e to the t times 2, right? And then 3 over 10 e to the 3t, and then 4 over 10 e to the 4t. So that is the moment generating function for x. You can see x1, right? The same moment generating function for x2. So the moment generating function for y will be a multiplication of them because it's additive, right? So it's going to be expectation of e to the t times y, right? That's how this one is defined as a equal to expectation of e to the t x1 plus x2, which then will be a multiplication of the exponential function. Therefore, it's going to be the multiplication of the two moment functions. So mx1t times mx2t. It should be how we calculate it. So we end up having a big multiplication here. That we don't have any better method than have to multiply out. So this is multiplying itself. So it's going to look like this. All right. Then we have to clean up combine the like term when we are trying to multiply. If you multiply the first one with the first one, this one with this one, you'll be getting 1 over 100. So that should be the probability. So 1 over 100, and then e to the t times e to the t is e to the 2t. That is indicating that the probability that y equal to 2 have a 1 over 100 probability. You know, if that's in way, I should notice that earlier. All right, so then we have higher value. Like, what about each y equal to 3? So you move on, and let's say if you multiply this one with e to the 2t, and we have e to the 3t. That will be 2 over 100. But then if you multiply 2 over 10 with 1 over 10, that one. So then there's 2 of them. Let me see if I can catch them. This one time this one is e to the 3t. And also this one time this one is also e to the 3t. If you combine them, it's going to be 4 over 10 because you got 4 over 100. So it's 2 over 100 and another 2 over 100. So we have e to the 3t. I guess that's all the possible e to the 3t, right? And then the next one should be e to the 4t. You will see there are more ways to create each one. it. So let's see what was the coefficient for e to the 4t. Okay, so it could be this one time e to the this one, right? And then it could also be this one time that one that was e to the 14. It could also be this one time that one that was e to the 14. So we have 3 different ways to have e to the 14, right? So altogether with this, that is 3, 2 times 2 is 4, and then 1 times 3, that was 3. So 3, 3, 4, which is 10, right? 10 over, so coefficient will be 10 over 100. That was that one. And then after that, we have e to the 5t. The last one you can see is e to the 4 and 4. 4 plus 4 is e to the 8t. So essentially, we're finding all these probability using the coefficient. This one's supposed to be e to the 5t. After that, we should have e to the 6t. And we have to be carefully when you try to determine the coefficient. And after that, we have e to the 7t. The last one is e to the 8t. And there's only one way to have e to the 8t. That one I don't have to doubt. So it's 4 times 4. That was 16 over 100. And anything in the middle, we have to look at how many combinations to give you that one. You have to carefully calculate it. Any questions so far? There may be more systematic way to do this. I wonder if I had it on my the solution I provided. You can make a table just to catch all the different combinations. At home, sometime I'll spend time and make a table. Yeah, this is a table. So we be 1, 2, 3, 4, 1, 2, 3, 4, and then you have all these multiplication in charts. That's what we're doing. So that you can see how many ways to create. Well, I did it. I was using that table. Okay. I actually did the probability table rather than homogeneous function. So that's a completely different approach than what I'm writing, right? But still, it should be similar. But anyway, you can look up that way. I did the table. Sorry, the calculation. But let's see. Let's see if that's how to do it slightly different so we can catch the coefficient. Okay. Right, so when you have to multiply multiple things, and sometimes it's a little hard to catch all the coefficients. So what we can do is try to make a table for this. The table for the multiplication, kind of like this. You might have seen this table before. So these coefficients are going to be the coefficient like 1 over 10 e to the t and 2 over 10 e to the 3t 2t, and then 3 over 10 e to the 3t, 4 over 10 e to the 4t. And then we might copy this over just to save time. All right, and then you can see the cross multiplication. If you make this into a chart, and then we can catch the coefficient faster. So this is 1 over 10 times 1 over 10. Just write a coefficient that will be 1 over 100. And then this you multiply, that was 2 over 100. If you multiply these two, that was 4 over 100. I stopped writing the e to the t. And this is going to be 1 and 2. That will be 2 over 100. Right, and this is all e to the t times e to the 2t. This is e to the 2t. E to the t to the 2t, that is e to the 3t. This is e to the 2t. That would be e to the 3t. We're supposed to add the power. And this is going to be 2 plus 2, that was 14. Right, so we can multiply across the table, and then what was missing? E to the 5t. Okay, for example, what is e to the 5t? It would be this is 4/100 e to the 5t, and then 2, 3, which is this one. We'll get 2 times 3 will be 6/100 e to the 5t. And then it looks like it's a diagonal, so this is e to the 5t as well. And the coefficient will be 2 times 3, that was 6/100. And then this one is e to the 5t because you have e to the 1t times e to the 4t. And then the coefficient is 4/100 as well. So there is a certain symmetry to it. Doing this way, it's easier to catch the number and also easier to find the pattern. If you add it all together, that was 20. So the coefficient will be, like this one, will be 20/100. Right, and then you can gradually catch all the other ones. So making I call them a multiplication table. And like the last one will be, this one would be e to the 6t. And the coefficient will be 4 and 8, that was 4 and 2, so 8/100. This will be 3 and 3, that was 9/100. This is also e to the 6t, and then this is 4 and 2, that is e to the 6t, and coefficient is 2 times 4, that was 8/100. So 8 plus 8 was 16, 16 plus 9 was 25. So this is 25/100. So we can see the probability. The question A is try to create a probability for x1 plus x2. So for y equal to 2, probably 100, y equal to 3, probably is 4/100, y equal to 4, and so on. So all these coefficients are what we are calculating, they are the probability value. So this really provides a systematic way to come up with the probability. On the solution I provided online, you can see these are created using this table. I made a joint distribution table. So how did we get that table from? It was really a multiplication. So 1/10, 1/10 multiplied 1/100, 2/10, and then 1/10, that's 2/100. 2/100, 3/100, 2/10, 2/10, 4/100. So you would figure out the joint distribution table, and then you can find out the summation from the summation table is from the joint table. For example, y equal to 2 is 1 plus 1, and then y equal to 3 is, this is a 3, this one and that one, that one, and then if y equal to 4, that's diagonal, right? It really is adding the diagonal. It felt like very similar to what we're doing in this multiplication table, right? It's a kind of different way of writing the multiplication table, but this table we're doing the multiplication of moment generating function. With that one, we're just multiplying purely the probability. This is really an illustration for two separate methods and how we do it. It felt like this one is more writing, but I think it also is more systematic. The benefit of doing this is you don't have to do two separate tables like this one. You gotta have the joint distribution table in order to get that distribution table. The rest of the question was to find out the mean and the variance for the y. So if you already have the distribution, of course, you can calculate the expectation by multiplying probability with the value. You can calculate the variance by calculating the expectation of the square of the value times probability, and then minus the mean squared. So don't forget the subtraction part. Very common for us when we calculate the variance, we forget to minus the mean square. That was calculating that one. But if you already have the moment generating function, you can also find the derivative, right? Find the derivative of it, and that will allow you to calculate the mean and the variance as well. So moment generating function provide a like complete set of methods for calculating first moment and second moment and variance. That's question number 2. We had the number 3 on test 3. That's the same question, I felt like. right? The same question that we had with final exam practice. Number 4 is an exercise for 5.2, where we have two variables, x and y are two variables that was given as exponential distribution. We want to find the distribution of u and v, the joint distribution of u and v. And we do very similar things. You find the inverse transformation to substitute the x and y. And then after you substitute it, you also have to multiply the derivative matrix determinant. Okay, so here is, I guess my writing in class tend to be not as organized as was writing at home. All right, but the underlying approach is you will be able to determine a joint function, joint density for x and y. Because they're independent, equal to f of x times f of y because of the independence. Now f of x, because there are exponential distributions, you would have 3e to the negative 3x. That's because we were given the lambda. If you were given theta, you would have to do 1 over theta e to the negative x over theta. But if you were given lambda, you would do lambda e to the negative lambda x. So it's two different ways of writing your exponential distribution, right? And they're identical. It says identically distributed. So f of y will be 3e to the negative 3y. Okay, so these are multiplication of the density for x and y, and that is our joint density. So this will equal to 9 e to the negative x plus y when we combine things like this. So we're going to apply this. You can use the inverse transformation, substitute x and y, and then we're able to construct the density function for the joint density for u and v. Right. So number one thing is we're going to find out what do we substitute for x and y. We're going to find the inverse transformation. In here we have this transformations. The v is a fraction and the u is a summation. If you add it to exponential distribution, the u would definitely be positive. But if you have a division, the division is a fraction between 3x and 2x plus y. This fraction, I'm not sure. I think it's still positive for sure. V is positive, but whether it has a lower boundary or not, that's a question. Okay, so it might be, I think, boundary is 1. I'm not sure about the domain of the V, but let's find the inverse transformation first. So u is equal to, so we get rid of one of the variables. U is equal to 2x plus y. Typing is bad. Let's try to type. So u equal to 2x plus y. And then we multiply the denominator. So v times 2x plus y will equal to 3x. That was the second transformation. Realize that the 2x plus y actually equal to u. So that means u times v equals 3x. And that gives us the way to write the x value. So as a result, we are able to represent the x. X equal to u times v divided by 3. That was one inverse. That allows us to substitute this x with uv over 3. And then we also have to find a way to write the y value. Now, back to the first equation, y is equal to u minus 2x. Since x equal to this, so then it equal to u minus 2 times uv over 3. So that gives us a way to rewrite the y. Now well, let's simplify that. U is a common factor, so bring the u outside, and we have 1 minus 2v over 3. And that equal to the y. And we'll substitute this to where the y is supposed to be. So that's our inverse transformation. Are we okay so far? Are we okay so far? So we substitute that this formula for the x and this formula for the y into the transformation. Then that one, after u will be being substituted, multiplied by the derivative matrix, which will be the actual density function. That's the idea of it. And the solution, you can see the solution x equal to uv over 3, y equal to u minus 2 times uv over 3. Right? I think we can factor the u out just so it's easier. And you substitute the x, y in there. We also have to find out the determinant of the Jacobi matrix. So find the derivative of x, partial derivative of x. We find the partial derivative of the y, those two. And then we cross multiply and subtract. Some of the term will be canceled, so we have that as the Jacobi matrix value. The u is positive, so we take the positive of the j. We find the absolute value of the j, which is u over 3. And that was the answer to the density function. Right, this is the explanation for how we find the domain. I was worried about finding the boundary of v. V was defined by a fraction, so you can use the fact that the x and y, they're both positive. So x equal to uv divided by 3. So since x is positive, that means u and v both have to be positive. That gives us a lower boundary. Because y is positive, y equals this. All right. Because y is positive, therefore we have these two is bigger than 0. And then since u already is positive, this is bigger than 0. That gives us a boundary for v. So basically, it goes with what we originally is having, like the domain for x and y itself is causing us to have the domain. So this is bigger than 0. This is our y value, which is also bigger than 0. And they are giving the natural boundary for u and v. So if you are having a little bit worry of how to determine the v, u and v's boundary or the domain for u and v, they're normally constructed using the domain for x and y. So, for exponential distribution, the only boundary that we have is x is positive and y is positive. That was the boundary, and that will allow us to create inequality. So this is telling us u got to be positive and v got to be positive. And this is telling us that u got to be positive and 1 minus 2v over 3 got to be positive. With that, we have the upper boundary for v. So that's the domain. So having the right density means you got to have the right formula. You also have to have the right domain for your variable. Any question? Basically, I think the solution itself is pretty complete. If there is anything that's not clear, is that last part of it. The reason we have that part is because y is bigger than 0. So if you have a formula for y, and then the y formula is bigger than 0, and that's why we get the v less than v over 2. That's where we get that domain from. It's number 4. Let's try to make sure we got all the other one. Number 5, we have a joint density function that we're given, and we want to find the fraction of the population such that find x is bigger than y. When you see fraction, we actually mean probability. To calculate this probability, you calculate a double integral. Okay. So the calculation here, we're really calculating probability that x is bigger than y. So you're going to look at your domain. Our domain for x and y, drawing it, is between 0 and 2, and then y is between 0 and 2. So this is domain. If x is bigger than y, that means y is less than x. So if you draw the line at y equal to x, this is the line y equal to x, and now the integration region should be below this line because y is below x. So this is the line y equal to x. So y is below the x and it's lower the shaded part. So our integration boundary would be, we're calculating this probability as a double integral, so integration boundary is, let's say we d y, it's the same anyway, so x plus y. If you are doing dy first, and then the lower boundary will be 0, the upper boundary will be x. And then outside it will be dx, and the x would have a numerical boundary, so that would be 0 to 2. Okay, so you determine what you were supposed to calculate, and then follow the integration, your calculation practice for integration will be the rest. And that will be the calculation. It depends on the domain. In this one, we have symmetric boundary. Even if the boundary are not symmetric, for example, if you have a slightly wider boundary on one end, for example, instead of 0 to 2, if you have 0 to 3, then this will all be x. So then if that's the case, then this got to be 0 to 3, and then here you might have to add that part of the probability, which is really a rectangular shape of the probability. The probability will be higher if the underlying domain is not symmetrical. I'm saying that not only do you have to calculate this, if this is changing, then this is 0 to, right? You might have to plus that part of the probability. That's question number 5. And you do have to think about whenever what's fitting the description for the integration. Your description dictate what kind of integration region you will be using. Number 5. Number 6 is we're trying to determine, again, a probability calculation. I want to find the value k that's appropriate for the integration. Okay, the basic idea is this. So the appropriately defined parameter k should have a double integration of f of xy dx dy, which equal to 1, right? The overall probability of the integration of density should equal to 1. So here, the integration boundary is going to be, for the y is 0 to 2. So 0 to 2 for dy, 0 to 3 for d3. You're plugging that into the f of xy. And that allows you to bring out the k and calculate the double integral. And then k should be 1 over the integration value. Any question? That's how do we determine the k. And then the second question is to calculate probability of x plus y less or equal to 2, right? Let's see the integration boundary. The x is from 0 to 3. This is one of the examples I should talk about. So you can see it's not symmetry. 0 to 2 on the y, but 0 to 3 on the x. And here you're going to determine a line x plus y equal to 2 is a line. There's 1, 2. So this is the line. This is a line that x plus y equal to 2, because you got 2 for the x is with y equal to 0, x equal to 0, y equal to 2, y equal to 0, x equal to 2. That's why I'm drawing the 2, connecting them. And we have x plus y lower than 2. So the region that we were supposed to integrate is right here. So when you set up the integration boundary to calculate the probability, this is going to determine the integration limit. Once you find the k, you gotta find the k first. So this is equal to dx depends. Let's say with dx. Okay. So if you dx, then it's the y value will be 0 to 2. And the x value will be 0 to, so what's the x? X is going to be, x is equal to 2 minus y. 2 minus y right here. And then you're going to have your k with the k. You're going to have the k calculate it. Is 1/18. So you will have a 1/18 x squared. This is dx, and then dy. So that will be the calculation to get the answer for part B. Any questions? It looks like our time is up. Most of these question solutions are already posted, and if you have any problem solving it, you're welcome to ask questions in your email. But overall, this is a take-home exam. The solution there is for you to study and compare, fully you can answer the test question. That will be it for today. Thank you.